Uh, Let us discuss about the pneumatic systems. As we have already discussed about this hydraulics and hydraulics fluid power systems in the first and second module, let us, before we get into this third module for the components and hydraulic circuit design components, let me talk about pneumatic systems. It is only because the few of the valves, something like pressure control valves, flow control valves, and the different pressure compensated. So these different valves quite common, which stands quite common for the both hydraulic and pneumatic system. Maybe the capacity keeps varying. So for that reason, let me talk. I just thought that let me talk about the pneumatic power systems, wherein which we will be discussing about the pneumatic power systems and its advantages, limitations, and its major applications. What are the we have all, while talking about fluid power systems, we found what are the different applications and what is the importance of hydraulic systems. Quite similarly, let us see what are the different applications in the pneumatic systems, and then we shall talk about the characteristics of the compressed air. It is only because in the hydraulic systems we use a compressed oil as an energy source, whereas in the pneumatic system we use compressed air as an energy source. And then, if we are using a compressed air as an energy source, what are its characteristics and how it will be generated? In the hydraulic systems, the pumps are used to increase or to create the pressure of an oil, whereas in the pneumatic systems, we use compressors. Then, how these compressors will work out? And then we shall also discuss about FRL unit. No, popularly this FRL unit is being termed. Basically, this F stands for the fluid, and I'm sorry, F stands for the filters, R stands for uh, the dryers, and L stands for the lubricating systems. Okay, then we shall also talk about the actuators and control valves. Then we shall go for the control circuits, whereas these control circuits as well as the logical gates, which includes, comes to be in the next module. Now let me talk about pneumatic systems. A pneumatic system is the one which uses a compressed air. The energy which is stored in the compressed air will be used as an energy source for operating. And this, if you want pneumatic systems in a definition wise, a pneumatic system is a tool. A pneumatics is a tool or a system, or we can also call it as a one procedure where a worked basically which worked basically on a air pressure or a compressed pressure or the airflow. Therefore, the force or a work or a displacement generated based on the general law of air pressure and flow. My dear friends, whatever may be the principle of working, but still this pneumatic system also works on the basic principle of Pascal's law. Okay, basic principle of fluid power or the air, the pneumatic power, both works on the basic principle of Pascal's law. Is it clear? Now, pneumatic is an actuator using the air pressure as their source of power. In pneumatic, the study of pneumatics deals with the system operation with air or gaseous medium to impart power or to control power. Neither it can use the air or any gas. Any gas, that means any medium which is in a gaseous state, is used to impart power to control the pneumatic systems. Okay, the term pneumatics basically it's a Greek word. Pneuma means wind or a breath. Okay, so pneumatic power is the power that is transmitted by pressurized air or compressed air. Basically, my dear friends, now I have given a simple a line diagram or a flow chart. The normal air is being taken to the compressor. Compressor, you must have seen it, my dear friends, whenever you go for any workshops to inflate your bike or bicycles or a car, to inflate the air to the tires and the wheels. There will be a one green color. Majorly, in most of the occasions, green color. A dome-like structure will be there, which will start running. So, which takes an atmospheric air and compresses it to a higher pressure. Then from the output of the compressor will be our compressed air. Compressed air means air which is of higher pressure. No, I was talking about, my dear friends, a normal air group. What is the difference between a wind and a air? I was talking what is the difference between a air and a wind. Air is something which is surrounded by us. A wind is the same air when it comes with some velocity. The same air, we are not talking about any specialized air. The same air, when it comes with certain velocity, then we call it as a wind. Got my point, madam? The same air with some kinetic energy is called as a wind. What do you mean by a pressurized air or a compressed air? The same air with a pressure energy is called as a compressed air or a pressurized air. So this point is to be noted when we talk about the characteristics of the a compressed air. Is it clear, my dear friends? Then it will be sent to the actuator using a control valve. Now, here we have a control valve, whereas in the pneumatics, in the hydraulic systems, we used to have a pressure relief valve or a pressure control valve will be there. Okay, then it will go to the actuator. Now, my dear friends, please be careful here. This actuator is a common part whether you take a hydraulic system or whether you take a pneumatic system. Tell me why. I'll tell you why. It is only because, friends, whether you have a hydraulic energy or you have a pneumatic energy, it doesn't mind. Ultimately, what we are looking out is only to get a mechanical energy as an output. Even in the JCB, we are not worried with what energy we are moving our arms or taking the load and getting it back. Is it right? So the actuator is nothing but we have already discussed number of actuators and varieties of actuator and properties, all these things. Actuator is the one which is which converts some sort of energy into a mechanical energy. Okay, that is first thing. Second thing is actuator is the one which is in actual motion for any hydraulic or a pneumatic systems. Don't get confused. Now, even when I talk about different type of actuators, here also I will discuss a piston actuator, piston type or a rotary type or a linear type. I will discuss the same thing, but the capacity and the applications will be different. The same rotary actuator which I am using it in a pneumatic system will be of lower capacity which takes the compressed air and works it out further. Same rotary actuator I will use it for the hydraulic system, but it will take the compressed oil and it does the same work. Is that clear? Now, I have already told you pneumatic systems in the first module itself. We have discussed the difference between a hydraulic system and a pneumatic system. One of the major difference in the pneumatics is that the capacity will be less. That means load carrying capacity is less in the pneumatic systems compared to the hydraulic systems. Friends. Okay, here is a one. I'm just comparing it with the electrical one. When we are talking about the drive systems, when we are talking about the drive systems, we talk about hydraulic, pneumatic, and electric systems. Now, let me compare with the pneumatic and electrical. Now, here in the pneumatic systems, we are using a air pressure. Here, we are using electric current system. Now, even in the robotics, they use a electric because robotic systems are where a sophisticated, a compact one is required. Correct. So in such cases, we cannot go for a compressor, we cannot go for a pump, all those things. But we will go for electric system because we want a neatness and no leakages are been. Uh, Leakages are almost 0% in electrical. In such kind of cases, we go for example in robotics we go for electrical system. If you compare these two, the power source is an electric current and air pressure. Controller component is a transistor over here, whereas here a directional valve. Okay, directional control valve now we also popularly call it as DC valve or DCV anta kariತೀವಿ ನಾವು. It is nothing but directional control valve. Here we use it as a transistor. In the signal delivery, it is very slow, whereas it is very fast. It is quite natural because it is just an element, okay, which it just carries out the movement of the airflow. Whereas here it is an electrons, my dear friends. It moves quite faster. Okay, now this is an energy conversion system. It is very strong, whereas this is weak. Obviously, it is only because when it comes to the capacity, hydraulics stands first and then pneumatics, then the electrical one. No, this is the one. Actuating devices, final control elements. This is only I have given it you in order to give the comparison when you want to have a differences. In the pneumatic systems, we use the cylinders, whereas here cylinders are very much required because we want to convert this pressure energy into the mechanical energy. Actuators completely demands these cylinders. Okay, now motors and linear motors are used. Directional control valve as we have already. Logic valves will be there. Logic valves I will not go in deeper. It is only because the next module we have to discuss only about this logical valves or nor not and gates. Maybe you have familiar with this in your first year engineering. Or gate, not gate, or nor gate, and gates. Is it clear? Don't tell me you have a but gate also. But is not there. It's only or, nor, and gates are there. Logical gates. That is what we call it as a popular logical gate. This is amps. There will be a button valve, and this can be a button or as well as switch valve can also be there. This is the air pressure, and this is a battery will be used. Okay. Now this is a but the flow will be the same as you can take it from the bottom. Energy supply, input elements, processing elements, final control elements, and actuating devices. Okay. Now this is the one you can go through this. Command execution. These are the working elements. Working elements, cylinders, motors, and optical indicators are being used. Whereas here in the signal outputs, control elements, ECVs are used. In that during the signal processing, this completely one which stands for the pneumatic systems, my dear friends. What are the different this one? Signal processing. Processing elements are DCVs, shuttle valves, dual pressure valves, pressure sequencing valves, and sequencers are used. The basic signal inputs are push button directional, control valves, control lever valves, proximity switches. Proximity is the one sensors which senses the distance. Air barriers are used. In the energy supply, energy supply elements are compressor, pneumatic reservoir, excuse me, pneumatic reservoirs, pressure regulating valves, and service units. So energy supply, signal input, signal processing, signal output, and command execution. Now here in the command execution, the actuators will come into the picture. Okay. Working elements. Can somebody tell me what do you mean by a single acting and double acting? Fernandez, what do you mean by single acting cylinder and what do you mean by double acting cylinders? Because we have already discussed the same thing in hydraulic systems also. I told you only the working medium does changes, but the principle of the cylinders, everything remains same thing except fluid. You are using compressed air. That's it. Fernandez, can you please tell me what is this single and double acting cylinders? Abhishek, Parangi, Abhishek, you're there?
Yes, sir.
Can you please tell me what is the single and double acting cylinders? If you know, yes, you should tell. If you don't know, you should tell me that you don't know. Simply don't waste.
No, no,
You don't know. Then what did you learn from the first module? What did you learn from the first module, I say? I have asked this question for the test also. Is it not, my dear friend? Can somebody tell me? Soundarya?
Sir,
What do you mean by a single or double acting cylinder?
a single acting cylinder creates force in one direction, sir,
Hmm.
and double acting cylinder it works both directions. Dispatch.
Work both the directions means the power will be generated or the work will be done when when the piston is moving in both the directions. Is it right? Correct, Amma. Correct. Now, can you please tell me, Parangi?
sir.
Now you tell me what is the single acting or what is double acting cylinder
In single acting cylinder, we can get power from one direction, sir.
in
In
one
double
direction.
acting,
So
we
that
can get
means
both.
cylinder, when the piston is moving in only one direction, if the work is being generated, then we call it as a single acting cylinder. When the cylinder is moving in both the directions, both in right direction as well as in the left direction, then we call it as a double acting cylinders. So this is what even we have already discussed. If I'm not wrong, I will show you the images. Now this is a double acting cylinders where the work is being done both during extension stroke as well as return stroke. Whereas in a single acting cylinders, now here you can see it here. I'm so sorry. In a single acting cylinders, the work will be generated only when the piston is moving in one direction. When the piston is moving only in the one direction, whether it may be in an extension or a return stroke. Now in this particular figure, work is done only during the extension stroke, and in the return stroke, no work is been done. Whereas here, in the double acting cylinders, what happens? Both the directions, either when it is extending or even when it is retracting, in both the directions, the work will be done. That is why we can see this piston rod, which has been placed both the directions. Need not necessary that piston rod need to be on both the directions, and even there are few double acting cylinders where the piston rod will be on only on one end, but still it will be does in both the directions. Do you understand my difference? So this is called as a double acting cylinders and single acting cylinders. Now this is one of the major element for this hydraulic systems. Now pneumatic uses, some examples I have given it here. Now you might be taking football, basketball, or even the volleyball, where you will inflate it. How do you inflate it? So the air which has to go inside this means you have to pressurize it. So this is what inflating these balls is one of the best example, or the what day to day every day you will find this. And inflating your tires and tubes, that is what I have already told you. And then this is what a crushers are, the people you might have seen it, where they will drill a hole in the stones, or even in the roads when you want to take the old road, the tar has to be removed, they will go for this such kind of things. Is that clear? Now even the nowadays, to make the holes also they will use it. Okay. Pneumatics are also used in a lot of in industries applications. It can be used to lots of different jobs for moving, holding, or shaping objects. So this is a moving object, this is a holding object, and this is a forming object, and this is a processing. So everywhere these pneumatic systems have been used Is it clear? Forget about all these things. Even in the doors, automatic closing and opening doors of buses. You might have seen it. A driver will operate the doors closing and opening in the city buses as well as in the major buses. How it will be operated? There will be an L shape. Pneumatic system will be connected to the bottom or top of this door. It operates on the pneumatic systems. See, this is about the painting one, dismantle or the automaton. No, in the olden days we used to put the spanner and we used to rotate it. Now, even for tightening the nuts and bolts, there is a pneumatic systems are there. So dismantling in the automobile paintings, a heavy duty pneumatic jackhammers. So these are all the jackhammers which you use it, and then filling machine, a dental drilling. Dental drilling, it's a very low capacity pneumatic systems are used. You might have seen it. Okay, then fill the tire with compressed air to adjust the tire pressure. That is what we call it as an inflating. Different applications of the pneumatic systems. Industrial applications, materials handling, clamping, shifting, positioning, branching of material flow, packaging, filling. Packaging and one example I remember now, very popular junk foods. You people like it. Chips packets. If you take the chips packet, it will be always filled with some air also. Have you observed it? In most of the packaged food, they always fill the air. So that is also comes under this packaging, filling, transfer of materials, sorting of parts, stamping, and embossing of components, and then drilling, turning, milling, sawing, finishing, forming. These are all the different applications and different nature of industries are being used. Even the toll gates, you might have seen it. It operates. And even this is a processing unit. This is a moving unit. See, these are all the different pneumatic applications where they use it. Comparison between a hydraulic system and pneumatic system. Maybe, my dear friends, this question might be asked in the first module, in the introduction module as well. And they can also ask in the similar in the pneumatic system. My dear friends, this comparison and the same table I have also added in the first module, and I'm also adding here because it has been there in both first module as well as in the pneumatic models. So I'll quickly go with this. It employs a pressurized liquid as a fluid. It employs a compressed gas, usually air, as a fluid medium. An oil hydraulic system operates around 700 bars. Now you can see it here almost 1 is to 70. 1 is to 70. That means 1 is to 70 times it is of which generates higher pressure here. Is it clear? So this is a hydraulic system operates at higher pressures, and this is a pneumatic system which operates at 5 to 10 bars. Generally designed as a closed system, usually designed as open system. Okay, this is used as an open system. It is only because the air which is available in the nature is free. It is available everywhere. So no need to carry any closed loop systems is not necessary to be maintained. So that is the reason why they use it. So that is not possible during the hydraulic systems. Generally designed as a closed system, usually designed as open system. That is what. The system slows down when leakage occurs. Here, the leakage is a major problem in the hydraulic systems. I was just talking about hydraulic system has got a maximum capacity. If that is the reason why they are not using it in most of the applications. The major disadvantage, as we discussed in last two modules, major disadvantage of this itself is the leakage problem. That is the reason why we talk about so much of sealing materials, all those things. What are the problems we come across with the leakages and all those things? Leakages does not affect the system much. I'm not saying it doesn't affect. Even in the pneumatic system also it affects upon, my dear friends. It is not, please read the sentence carefully. It doesn't affect the system much. It is only because it is an open system. That means there will be continuous suction can be possible during the pneumatic system. That is the reason why when compared to the hydraulic system, it is not affected much. Is that clear? It doesn't mean that it won't affect at all. Okay. Next one is valve operation are difficult. Then the valve operations are easy. It is only because of the capacity. Nothing else, my dear friend. Obviously, when it is open system, it is lighter in weight. Obviously, it is heavier in weight. Pumps are used. Please make a note of it. Pumps are used to provide pressurized liquid, whereas the compressors are used to provide compressed gases. Is it clear? The system is unsafe for fire hazards. The system is free from fire hazards. It's only because we are not compressed air. We are not compressing it. So you can ask me, sir, compressed air is used in IC engines. That is the CI engines we use it. We use it in a different purpose and the diesel will be there for the combustion and the compression ratio will be very high. We are not using in such a high compression ratio, my dear friends. Don't correlate this with that. Okay. Now, because the engine oil are most of the cases we use the hydrocarbons oils in the fluid power system, so it is an unsafe hazardous can be takes place. Automatic lubrication is provided. It is only because the capacity is more, the friction will be more, and obviously the heat generated will also be more. So we go for automatic lubrication system. Whereas here the special arrangement for lubrications are required. Advantages of pneumatic systems. It is a clean. Obviously, when I'm talking about this pneumatic systems where the leakages will be just a air. In the hydraulic systems, you can take the leakages is an oil. So neatness will not be there, cleanliness will not be there. So the pneumatic systems are clean because they use compressed air. If a pneumatic system develops a leak, it will be air, that's all. And it escapes out, not an oil. This air will not drip or cause a mess, which makes pneumatic suitable for food production lines. That's it. Okay. Next one is what he says is this cleanliness is more important when you use this system in a food processing unit. Say, for example, you are using a hydraulic system in a milk producing system, or it may be in a food producing system. If there is a leakage of oil, that leakage of oil is not supposed to mix with the food which we are packing it. Is it not, my dear friends? If the same thing, pneumatic system is used, even in the worst case, if the leakage occurs, only the air will come into that picture. Is it not? The air, even if it mixes with the food, it doesn't make much difference to the quality or a taste of the food. Safe. I was just talking about the hazardous things. It is safe. It is only because pneumatic systems are very safe compared to the other systems. We cannot, for example, use electronics for paint spraying because many electronic components produce sparks and this could cause the paint to catch fire. Even because a small percentage of alcohol or things will be there in the paint. Is that clear? And short circuits may also happen. Is it clear? For that reason, it is safe. Pneumatic systems are very safe compared to the hydraulic as well as the electric systems. It is reliable. Pneumatic systems are very reliable and can keep working for longer time. Many companies invest in pneumatics because they know they will not have a lot of breakdowns and that equipment will last for a longer time. That means I mean to say that reliable means maintenance is easy. Is it clear? Next one is an economical. If we compare pneumatic systems to other systems, we find they are cheaper to run. This is because the components last for a long time and because we are using it a compressed air. Is it clear? It is flexible. Once you have brought the basic components, you can set them up to carry out different tasks Pneumatic systems are easy to install and they do not need to be insulated or protected like electronic systems. This is what the major flexible advantages of pneumatic systems. Okay, this is what actually I just quickly, and you can see it here. This is a one clear picture. It's a compressed air. Initially, the air will be taken from the atmosphere with the use of filters only, my dear friends. With the filter, because the atmospheric air will also have certain contaminations or dust and dirt particles will be there. So, with the use of air filters, even in your bike also you will have an air filter, my dear friend. Okay. With the use of a filters, the air will be taken into the compressor and it generating section, and then the compressed air with a high pressure will be stored in a air storage section. This is what we call it as an air tank. Then it will be sent to the cleaning section. Even after the compression, if there is dust particles is there, that will be cleaned in the air cleaning section, where this is called as a mainline filter or air dryer. Now you can ask me, sir, why this air dryer is required? Now, my dear friends, in most of the occasions, the even in the atmospheric air will have certain percentage of moisture, and that moist air has to be removed. Okay, that is why the air dryers are used. Then the separator, mist separator will be there. This is all comes under the section of air cleaning, which will have mainline filter, air dryer, mist separator. Then we will also have air conditioning section. In the air conditioning section, filter, regulator, and lubricator will be used. This is what we call it as a FRL. This is a filter, F for filter, R for regulator, and L for lubricator. FRL unit is very important, which we call it as the air conditioning section. Then we will also have a controlling section where we will have a DCV and speed control. Where here the direction of the movement, say if you take this as a cylinder, if you take this as a cylinder, we will control. Say for example, if it has to be lifted, means the air direction will be controlled and it will be sent to the bottom portion of the cylinder. If the same thing has to be pushed downwards, then air will be directed towards upper part of the cylinder. So this direction will be controlled by the direction control valve, and the speed with which it has to be moved will also be controlled by the speed controller. The last part is nothing but an actuator, or we also call it, you can also consider it as a cylinder. Now this is an operating section which will have actuator, and different types of actuators can be used here. Now this is a compressed air generating section, air storage section, air cleaning section, air conditioning section, and then controlling section, and the last one will be our operating section. Okay. What are the uses of the compressor? What is the major work will be performed over here? Okay, next. The compressor. In the compressor, what happens? To gather and compress air from normal to high pressure. Those air compressors in which successive volumes of air are enclosed and then elevated to a higher pressure by reducing the volume of the enclosure holding air. This is what the use of a compressor. Air tank. It is only to receive and keep compressed air. The receiver should be fitted with a safety valve, pressure gauge, and to manage the pressure and air pressure. That is why, my dear friends, you might have seen it. Oxygen cylinders or any gas cylinders which have been stored, on the top of that there will be a one gauge which tells you what is the pressure of the air which is been stored in that cylinder. If you keep releasing that air, the pressure keeps decreasing. This is what we call it as a safety valve or a pressure gauge. Is it clear? Even this pressure safety valve will also be there even in your for pressure cooker also. Next to the visual, there will be one small hexagonal bolt will be there. That is for the safety. Is it clear? Now, next one is the air dryer. To dry the compressed air before it is provided to pneumatic system and to avoid pneumatic components from the corrosion. This air dryer is being used. That is the reason why the moist content has to be removed. The service unit. The service unit normally consists of three components. There are filter, regulator and lubricator. Its functions is to remove all contaminants such as dust and rust particles from the compressed air, manages this air pressure and to extend the life of pneumatic system components which need to be lubricated. Okay. Now the directional control valve determines the flow of air between its ports by opening, closing or changing its internal connections. So directional valve is used to control air and cylinder directions or movements. Actuator. Actuator is to perform the potential energy of the compressed air into mechanical work. That's it. The work done by pneumatic actuator can be linear or it can be rotary. The same thing holds good even in the hydraulic systems as well. Advantages which we have already discussed. Further points I want to add it over here. Availability, transportation, storage, temperature and explosion proof. That is what we have put it in the other words. Hazardous. Okay, cleanliness, components, speed and overload, safety will also be there. Pneumatic tools and operating components can be loaded to the point of stopping and or therefore overload, safety will also be possible. Okay. Preparation, when it comes to the disadvantages, preparations, compression and force requirement, noise level will be always there. Preparation, compressed air requires good preparation. Dirt and condensate should not present in the air. That is what major which we cannot, in most of the cases we cannot avoid it. Air purifiers, how much ever it may be there, the dust and dirt particles will enter into. Next one is compression. It is not always possible to achieve uniform and constant piston speed with the compressed air. It is only because the energy carrying or power carrying capacity of this air, which will be always falls below the hydraulic systems. That is the reason why we cannot achieve this. In the force requirements, compressed air is economical only up to only up to uh, uh, the compressed air is economical up to a certain force requirement. Working pressure output is small and limit between 40,000 to 50,000 newtons. That is 40 kilonewtons to 50 kilonewtons, dependent on the travel and speed. There is a spelling mistake in the travel. I kindly excuse for that. Then the noise level, the exhaust air is very loud and it makes a lot of noise. The composition of atmospheric air, it is not necessary, but still as a point of curiosity, I'm just giving it. It is a normal atmospheric air will always have a 78% of nitrogen and 20% of, actually 21% of oxygen and 0.98% of argon by volumetric analysis. Okay. It also contains the traces of carbon dioxide, hydrogen, neon, helium, krypton, and xenon. Apart from these gases, atmospheric air holds many harmful impurities like dust. I cannot say it is fully harmful impurities. Dust and moist content is meant to be there. We cannot, normal air, see my question, to be frank, that means animals, human beings, and even the plantations, we are comfortable in the air. It is only because of the percentage of humidity which is presented there. It is only because the small percentage of humidity is required for this. You just imagine, even in the summer, if the hot air is coming, do you feel comfortable breathing it? It is not possible. Is that clear? So it is, as a prospect of pneumatic systems, we say it is a harmful, like dust and moisture content actually. Air has a mass and exert pressure on the surface of the earth. You see, that will be there. Atmospheric pressure at normal scale bars. That means 101.325 kilopascals will be there. Okay, this is the air pressure. This air pressure which I shall continue it tomorrow because the time is getting over. The meeting will end up. Okay, let me talk about this air pressure and unit. Force is applied to the air enclosed in a chamber through a piston of air. This is the air which is there and the force has been applied. The enclosed air is compressed and its pressure raised in directly proportional to the applied force and inversely proportional to the area of the. This is what pressure is being directly proportional to the force. Pressure which is being generated by the air which is there in the cylinder is directly proportional to the air which is being applied onto this piston and inversely proportional or indirectly proportional to the surface area of the piston. Is that clear? The unit of pressure you must be knowing it, my dear friends, because you are already come across with many subjects wherein which 1 Pascal is equal to 1 Newton per meter square. 1 bar is equal to 1 into 10 to the power of 5 Pascals. For industrial, this is what 14.5, that is a pound per inches is equal to 1 bar. This system we don't use it. We SI systems we use it as 1 Pascals is equal to 1 Newton per meter square. Okay. This is a typical pneumatic system. Actually, my dear friends, I could not able to plot this, so just I have taken it as it is from the picture and have placed it over here. The meeting will end over in the 5 minutes, so let me take the attendance, my dear friends. Okay, the attendance is taken. Thank you. We shall meet tomorrow once again at 9 o'clock itself. Thank you.